Hello, everybody. Welcome back to Mathletes Corner. Today, we are going to be discussing combinations and permutations. So, before we start on an actual problem from a contest, let me just present something that introduces all of you to the idea of combinations versus permutations, how they're similar, how they're different. So, first, let's say that we have 5 students in a club, and we want to choose 3 of them for a committee. How many ways are there to choose the 3 students out of the 5 students? Now, these are pretty small numbers, so it's easy to just count all of the ways, but we're going to try to use a more combinatorial approach. So, there's 5 ways to choose the first student, there's 4 ways to choose the second student, and 3 ways to choose the third student. Now, we can't just multiply these 3 numbers because we counted the same set of students in multiple different orders. So say our committee is students A, B, and C. The first student we chose could have been A, the second could have been B, the third could have been C. But we may have also chosen B first, A second, C third. And we overcounted that many times. So because there's 3 students here, we overcounted 3 factorial times because there's 3 factorial different orderings of these 3 people. And when you evaluate that, the numerator comes out to 60, the denominator comes out to 6, and the final answer is 10. Now, this is what we call 5 choose 3. So 5 choose 3 is the number of ways to choose 3 students from 5 students. And that's how we define the idea of combinations. So n choose r is the number of ways to choose r unordered sets of objects from a set of n objects. So let's change up the question that we had before a little bit. Let's change it up a little bit. Now, say the 3 positions in the committee were president, vice president, and secretary. So we have 3 different positions. Now, choosing the 3 people in different orders is considered different because A being president, B being vice president, and C being secretary is different from C being president, A being vice president, and B being secretary. Those are 2 different scenarios. So, how are we going to correct our definition of combinations to do this problem? Well, that's where we get introduced to the idea of permutations. So earlier, when we faced this problem of different orderings of people, we divided by 3 factorial. But here, we do want to count them in different orders. So we just won't divide by 3 factorial. And our answer will be 5 times 4 times 3, which is 60. And this is how we define permutations. The number of ways to pick are ordered sets of objects from a total of n objects. So now that we've been introduced to the ideas of combinations and permutations, let's get started on the problem for this video. So this problem is the 2022 State Sprint Problem 24. Thomas, Carey, and Lenny each captain a different one of 3 hockey teams. Each captain will choose 4 players from a pool of 12 players, with each player chosen for only one team. How many different ways can the teams be formed? So, total of 12, and we choose 4 players at a time. So, to choose our first set of 4 players, we can just do 12 choose 4. To choose our second set of 4 players, well, now we don't have 12 players, we only have 8 players remaining. So we'll have to do 8 choose 4. And now we only have 4 players remaining, so we do 4 choose 4. Now, you may be thinking that because we chose 3 teams, we could have chosen them in different orders, we have to divide by 3 factorial. We actually don't, because we have 3 different captains. So we can say these go to Thomas, these people go to Carey, and these people go to Lenny. And now it's not different to count these sets of players in different orders. So then we can evaluate this. 12 choose 4 is 495. And 8 choose 4 is 70. And multiplying them gives 3, 4, 6, 5, 0. And that's the answer to this problem. So when we do combinatorics problems, it's important that we know what we're counting. We know if we're doing any repetitions that we're not supposed to, like counting sets in different orders when they have to be unordered. All right, gang, that's all for this video. Thank you for watching. Our channel drops every Sunday, so we'll see you next time here at Mathlete's Corner.